Hello, my name's Nate and welcome to my video on JavaScript prototypal inheritance. We'll be going through a few slides just to introduce some of the information, and then I'll be diving into the JavaScript console in Chrome just to give some concrete examples. Any questions, just leave them in the comments below. Now, to start off with, I just want to talk a little bit about primitive types and objects in JavaScript. Now, primitive types are things like strings and numbers, big ints, booleans, and these types do not actually have any methods, properties or prototypes associated with them. So you might be thinking, hang on a minute, I've called methods on strings before and accessed the length property and so on and so forth. So what's actually going on here? And what JavaScript actually does when you call a method or access a property on a primitive is it wraps it in an object, a wrapper object, which can then inherit methods from the prototype so that you can call something like to lowercase or access the length of a string. And as soon as it's performed that requested operation and delivered the result, the wrapper object just gets deleted from memory and then you're left with your primitive. So now that we've made that distinction, let's go on to talking about what exactly prototypes are. Now you can think of a prototype as being like a blueprint from which all objects are created. And everything which is not a primitive type in JavaScript is an object and ultimately does inherit from the object prototype. So things like functions, arrays, regular expressions, dates, these are just to name a few. All of these inherit from their own prototype, which ultimately inherits from the object prototype. And this is the mechanism that enables a freshly created array, for instance, to inherit such methods as for each, reduce, filter, etc., etc. And this mechanism works much the same way for pretty much every object within JavaScript. So how exactly does prototypal inheritance work? Now, when people talk about prototypal inheritance, you'll often hear them mentioning the prototypal chain. Now, the prototypal chain links the object that you've just created. So in the instance here, we've created an array. It links your freshly created array back to the array prototype, which is then linked back to the object prototype, which then links back to null, which indicates the end of the prototypal chain. Now this happens automatically in JavaScript whenever you create an object, and you can actually go and look at that object's prototype property and then see exactly where it's inherited its properties from. And one of the main key takeaway points of prototypal inheritance and prototypal chains is the way in which these properties are looked up when you access a method or a property on an object. So what actually happens when you try and access a method or a property on a freshly created array is it will first look at the array that you've created to see if the property or the method exists on that particular array. If it doesn't, it will then look at the array prototype, which is where most of our methods and properties exist. And if it doesn't find the method or the property that it's looking for on the array prototype, it'll then take another step up the prototypal chain to the object prototype. And in turn, if it doesn't find the method there, it's going to take another step up towards null, which obviously is the end of the chain. So if we dive into the console in Chrome, we're just going to explore what this prototypal chain looks like on an actual object. And the example we're going to use is the string wrapper, just with the string egg. So we're using the method getPrototypeOf, which is going to return the object's prototype, which we can see in this case is the string wrapper object. So our variable a represents the prototype of the string wrapper. If we then call object.getPrototypeOf on A, it'll show us the next step in the prototypal chain, which will be the object prototype. And if we then inspect the proto property, which is the prototype property of the object prototype, we'll see that that points to the end of the prototypal chain being null. Now, another method of accessing an object's prototype is to use the __proto___ property. Now, it is worth mentioning that this method is actually deprecated, though it is quite useful in the console just to get a quick look of the prototypal chain, because obviously it being a property, you can chain .proto.proto.proto and it will go right back through all of the prototypes in the chain, as you can see here. So if we now look at an example of an array being created and its prototype, exactly as the diagram that we looked at earlier, goes back to the array prototype, which then goes back to the object prototype, which will then point to null. And as a second example, we're just going to use the date object, create a new date, look at its prototype, obviously being the date prototype, the prototype of which is then the object prototype, and again, back to null. Now, one thing you can do in JavaScript that you can't do in a strictly typed language such as Java is change an object's prototype at runtime, which is what we're going to do here. So what we're doing is we're modifying the string prototype and adding a reverse method which will reverse a string. Now, while this is possible, it's not generally advised that you do this. And that's because if, for instance, the ECMAScript standard was to change, which it does quite frequently, and a reverse method were to be added to the string prototype, then you'd end up with a collision between that version and yours, which would cause all sorts of problems. So here we are, here's our reverse method working on a string. And if we look at the string prototype now, we should be able to see that our method has actually been added to the prototype. Now, one way of adding or changing the prototype of an object is just to modify the __ proto property of the object itself, which we can see we're going to do here with object 2. So if we set the proto of object 2 to be object 1, we can then prove that it's inheriting the property 1 from object 1 by using the hasOwnProperty method, which will show that it doesn't actually have that own property itself, but the property is inherited through the prototype of object 1, which will then inherit its prototype from object, which then again goes back to null. Another way to add a prototype to an object is to create the new object using object create and specifying the actual prototype that you want it to inherit from. So in this case, we're creating an object called another object, and it's going to use the prototype of object 1 from the previous example. And again, we can test that inheritance tree using hasOwnProperty and by exploring the object's prototype property. Another way to set an object's prototype is to use the setPrototypeOf method, and it accepts two arguments, one being the target object and the other being the source, with the source being the actual prototype that you want the target to inherit. And we can test that using the same methods as before, .proto. And one of the perceived caveats of JavaScript is the inability to do accurate type checking of objects. Now, type checking will work with primitive types. You can check one string against another to see that they're both strings, or you can check a string against a number to see that they are of different types. But with objects, regardless of what the parent prototype is of the object, an object's type will always be object. So it's impossible to compare the types of objects in this way. Now, you can't compare object types in JavaScript because JavaScript isn't a strictly typed language. But what you can do is use getPrototypeOf on two objects to compare the equality of their prototypes. Now, this might be useful in a case where you want to do a type check or add a type guard on an object to make sure that it's of the correct prototype or the prototype that you're expecting it to be of. Now, this is something that you might more commonly do in a more strictly typed language, just to make sure that an object is the object you're expecting before you call a specific method on it that it might not otherwise have. And as you can see here in the example, we are able to compare the prototypes of two different class instances, which is something that you wouldn't be able to do using the typeOf keyword. And that sums up this video. I hope that made sense. I am aware I went over some of those concepts a bit quickly. And if you do have any questions, put them in the comments and I'll do my best to answer them.